Welcome to July 25th LeetCode Challenge, non-negative integers without consecutive ones. Given a positive integer n, return the number of integers in the range of 0 to n whose binary representation do not contain consecutive ones. So for example, you have n equals 5, the output should be 5 because there are non-negative integers less than integers less than or equal to 5 corresponding to the binary representation as seen here. So 0 being 0, 1 being 1, 2 being 1, 0, 1, 1, 1, 0, 0, and 1, 0, 1. So among them, the only three of them disobey the rules. So with two consecutive ones, and the other three satisfies the rule. So I think actually the output should actually be 2 here, if I'm not mistaken, because there is 5 output, but there's only we want non-negative integers without consecutive ones, right? Yeah, so yeah, you just erase this number 3. There you go. Now the answer's right. Yeah, well, that's pretty much it. N is between 1 to 10 to the 9. So this is raised a hard question because it involves a specific concept known as combinatorics, and if you know this trick, it will help you a lot. But if you don't know this trick, it just becomes almost like very hard. So let's see. Let's consider a string or a number that starts off with a 0. We know the next one has to be a 1, and then one after that has to be a 0. So there's only a couple of patterns we can go about creating such a string, such a number without consecutive ones. And it turns out we find the number sequence between 0 and 1 without consecutive ones, and it follows something called the Fibonacci recurrence sequence, or Fibonacci recurrence relation, I should say. So you need to be able to count the binary strings of length n with no 2 adjacent ones in a row. And that's a common combinatorics type question. It follows the Fibonacci recurrence relation. And this is basically a mathematical proof for why that exists and the relationship that happens, but that's beyond the scope of what I'm trying to explain here. So we use binary representation of a number to traverse it from the start and check to see if we have 2 consecutive ones in a row. If we do, we break. If not, we add the corresponding Fibonacci number, and we're going to consider the 2 groups and check how many options we have for each of them, starting from the last one, and then it has less and less options every time we go along. So we're going to find all of them, and then we're going to find this relationship. Okay, so so if you know the Fibonacci number way of creating n numbers of strings without 2 consecutive ones, then it's simple. But if you don't, it becomes really hard. So let's say, using your intuition for this, if we have a sub n numbers of n binary digits, then the last number can either be a 1, then we have a sub n minus 2 options, or it could be 0. Therefore, we have a sub n minus 1 ways we can make a string. So, for example, if we have 5, we have and if we do all this kind of proof out there, we have basically a Fibonacci number sequence of 2 plus 3 plus 5 plus Fibonacci number of 8 plus Fibonacci number of 10. So you're adding all these various types of groups together. I'll show you a copy and paste of groups. So here are your possibilities that you have, essentially. Alright, so start with a 0. How many ways can you make a string from 1 to n, where n is basically, if you do 10 to the 9, then it means that you have basically 32 types, 32 digits in a row. But this is for simplicity's sake. So you have these groups here. So basically, if you have, for instance, let's say this group right here. You have x, x. So what could go after this? It could go 0, and then 1, and go 0, 0. And then, let's see, what else could you put? You could put, let's see, without consecutive ones. 0, 0. Oh yeah, and you can put 1, 0. So therefore, this group right here falls into this category, right? You have 2 requiring an input of 2. So therefore, you put for x, x, you can put 0, 0. You can put 1, 0, or you put 0, 1. Right? For this group right here, what can you put for x, x, x? Right? Which falls into this category. Well, after this, you can put 0, 0, 0. You could put 0, 0, 1, which still satisfies the sequence. You put this. You could put this. Then you could put this. So notice how this equals 5. 5 possible ways. Put an arrow there. 3. So if you have 3 numbers here, that means f at the third Fibonacci number will give you 5. Likewise, you do it for this, and you keep on moving up the chain, and you do the same type of relationship. So the next one is going to give you a whole 13 numbers. So let's just call it 13. The next one is going to give you 55. Next one is going to give you 144 cases. So this follows the Fibonacci recurrence sequence. And I want to use this idea to basically return these outputs, right, given the numbers we have. Alright, let's go about doing this. So we want to develop a string. We're going to take the binary number of num plus 1, because we want to take it there, and we want to take the slice between 2 to the n, and we want to define our length as well, length of nums, or n I should say, or s. Next thing we want to do is we also want to so we're given is n, so we're going to do that, and length of s, redefine n, so I'm going to say let's call n side, that sucks, call this nums, I guess, or call it, yeah, num. Next thing you want to do is create a dynamic program array from 1 to 2, plus we're going to make some space for it, star the n minus 2 term. Then we're going to do a for loop here for I in range 2 to n. What we're going to do is that we are going to define for another for loop, we're going to update our dynamic program array at index I to be the dynamic programming at I minus 1 plus the dynamic programming array at I minus 2 position. So in order to fulfill what we just explained earlier, what we want to do is define that. Then we're going to have a couple of variables to hold. So we're going to have a flag to make sure that we are flagging it if it's a possibility. So candidate, no, I'll call it flag. And we want our output. That's what we're going to return. It's going to be 0, 0. And what we want to do is do another for loop for I in range of num. If our string at index I is equal to the string 0, then what we're going to do is continue. If flag, however, is equal to 1, so we're going to make a Boolean flag, that is. We're going to break from this cycle. If I is greater than 0, and the string at index I minus 1 is equal to 1, then we're also going to change the flag, we're going to flag it. flag assigned to 1. And the output is going to be incremented each time because the output is going to be incremented as the count of our dynamic programming array at so it's going to be non-negative. So it's a tricky thing here, but it's going to be a negative number here, negative I minus 1. Then we want to return output. I in range. Equals 1. Oh, okay. Num. Let's see, S, take the binary of n to slice. It's going to be num, dynamic programming array, it's going to be 2 plus nums minus 2 for I in range 2 to num. Let's submit this. Alright, accepted. This is a hard question, for sure. It looks nice and concise here, but I did not come up with this myself. I do know about the Combinatorics Fibonacci number sequence, but to develop a code with binary flag, with the Boolean flag like this, it's not obvious. So time complexity is actually big O of n, big O of it's linear time. It's actually big O of 32 because we need 32 numbers to make a binary digits to make n to the 9. So because we use binary representation of the numbers. So we have unbounded. Let's say if this is not bounded to any constraints, so it would be unlimited. We would have big O time complexity would be big O to log n, right? Where m is the number of bits in the number that we need to give, so we need to have modulo as well for the Fibonacci numbers. Space complexity, we're storing everything in a dynamic program array, but we have an output in here that's a constant variable. So yes, we'll just call it big O of n squared. Nah, yeah, big O of n, I believe. Alright. I'm stumped, to be honest, and I'm glad this actually worked. Otherwise, take care, guys.